Chapter 9, Alcohols, Class Life Sciences. Part 1, Definition, General Molecular Formula, and Nomenclature. At the end of this session, students should be able to define alcohols, identify the general molecular formula of a saturated non-cyclic monoalcohol, write the systematic name of a monoalcohol. Introduction. Alcohols are organic substances widespread in plant and animal kingdom. They are responsible for the odor of some plants. For example, geraniol is the alcohol extracted from the orange blossoms. Benzyl alcohol is responsible for the fragrance of jasmine. In organic molecules, the main chain is the longest continuous chain of carbon atoms containing the functional group. Example, the main carbon chain in this organic compound is the one that has the longest straight carbon chain. That means 1, 2, 3, 4, 5. This is a carbon chain. 1, 2, 3, 4. This is a carbon chain. 1, 2, 3, 4. This is a carbon chain. The longest one that contains the functional group, which is the hydroxyl group OH, is the one on the line which is 1, 2, 3, 4, 5, 4 of 5 carbon. This is the main carbon chain. Then the main chain is the longest carbon chain that contains the functional group. That means the functional group is bounded to one carbon of this chain. The carbon connected to the functional group, or the one that is part of the functional group, possesses characteristic reactivity which distinguishes it from other carbon atoms of the chain. It's called the functional carbon. Then the carbon that holds the functional group, or it is a part of the functional group, gives the characteristic of the organic compound with the functional group. Then this carbon is called functional carbon. For example, in this compound, the hydroxyl group OH is the functional group. The carbon holding the functional group is this carbon. This is the functional carbon. In this organic compound, which is an aldehyde, the carbon this carbon is a part of the functional group, which is the carbonyl group. Then this is the functional carbon. Then the functional carbon could be the carbon atom that holds the functional group, or the carbon atom that is part of the functional group. One definition of alcohol. Alcohols are organic compounds that have the hydroxyl group OH as the only functional group. Alcohols containing one hydroxyl group are called monoalcohols, while those containing many hydroxyl groups are called polyalcohols. In this chapter, the study is limited to open-chain, non-cyclic, saturated monoalcohols. Open-chain or non-cyclic, that means the carbon chain has no cycle. Saturated, that means the carbon chain has no, or the carbon atoms have no double bonds between them. We have no double bonds between carbon atoms. A monoalcohol is a compound which contains one hydroxyl group OH connected to the carbon chain. the general formula of a monoalcohol is ROH. Then the hydroxyl group OH is the characteristic or the functional group of the alcohol. Any organic compound that has only OH as functional group belongs to family of alcohols. 2. General molecular formula. To determine the general molecular formula of any organic compound, we take an example. In this case, we take ethanol CH3CH2OH, which is an example of open chain saturated monoalcohol. Then we transform this structural formula into a molecular formula. The molecular formula of ethanol, we have 2 carbons C2, 3, 2, 5, and 1, 6 hydrogen H6, and 1 oxygen. Then the molecular formula is C2H6O. Always in general, the general formula of an organic compound, in general, the number of carbon is represented by N, and number of hydrogen by 2N plus minus or nothing according to the case. In this case, N equal 2, then 2N equal 4, but we have 6 carbon, then we should add 2 plus 2, then 2 times 2, 4, plus 2, 6, equal to 9. Then the general number of carbon of hydrogen atom equal to N plus 2, then we add the oxygen. Therefore, the general molecular formula of saturated non-cyclic monoalcohol is CnH2n plus 2O. Then it satisfies the general molecular formula CnH2n plus 2O or CnH2n plus 1OH. Therefore, the general molecular formula of an open chain non-cyclic saturated monoalcohol is CnH2n plus 2O or CnH2n plus 1OH. If we take another example, will the general formula change? We will see. For example, CH3, CH3, CHOH, CH3. This is an example, another example of alcohol. The molecular formula of this alcohol forms 5 carbon atoms, C5, and we have hydrogen 3, 6, 7, 8, 11, and 1, 12, H12, and 1 oxygen. In general, always CnH2n. N in this case, N equal 5. Then 2 times N, that means 2 times 5, 10. But we have 12, then we need to add 2 plus 2. And we add oxygen. Then CnH2n plus 2 is the general molecular formula of this alcohol, which is the general molecular formula of any saturated non-cyclic monoalcohol. The molar mass of an open chain saturated monoalcohol in terms of N, that means the molar mass of this general formula, carbon 12 times N, 12N, hydrogen 1 times 2N plus 2 equal 2N plus 2, and oxygen 16, then 12N plus 2, 14N, 2 plus 16, 18, then 14N plus 18 gram per mole is the general molar mass of a saturated non-cyclic monoalcohol. If we are given the percentage by mass of any element of the alcohol, we can determine its molecular formula based on the relation percentage by mass of carbon over 12N equal percentage by mass of hydrogen over 2N plus 2 equal percentage by mass of oxygen over 16 equals sum of percentage 100 over sum of molar masses, which is 14N plus 18. If we are given percentage carbon, we take percentage carbon over 12N and 100 over 14N plus 18, and we calculate N. The same for percentage H and percentage O. If we are given the percentage by atoms or by mole of any element of the alcohol, we can determine its molecular formula based on the relation percent by atoms of carbon over number of carbon atom, which is N, for CnH2n plus 2O, number of carbon atom N, equal percent by atoms of hydrogen over total number of hydrogen, which is 2n plus 2, equal percent by atoms of oxygen over number of oxygen atom equal 1, equal 100 sum of percent over sum of number of atoms, which is atomicity, 3n plus 3. Application: the percentage by mass of carbon atoms in an open chain saturated monoalcohol is 60%. Determine the molecular formula of this alcohol. Solution of application 1. First, we write the general molecular formula of a saturated non-cyclic monoalcohol is CnH2n plus 2O. We calculate the molar mass of CnH2n plus 2O in terms of N equal carbon 12 times N 12N plus hydrogen 2N plus 2 times 1 2N plus 2 plus oxygen 16 equals 14, 12N plus 2N, 14N plus 18 gram per mole. Now we apply the relation percent carbon over 12N equal 100 over molar mass. Then percent by mass of carbon 60 over 12N equal 100 over 14N plus 18. We calculate N. We find that N after calculation equals 3 by mathematical calculation. 60 times 14N plus 18 equal 12 times 100, 12N times 100. Then by mathematical calculation we can deduce that N equals 3, and therefore the molecular formula of this alcohol is CnC3 H2n 2 times C6 plus 2,8O. According to IUPAC, now nomenclature. According to IUPAC, International Union of Pure and Applied Chemistry, the systematic name of an alcohol is derived from the name of the alkane having the same number of carbon atoms in the main chain by replacing the final E by the ending ol. That means the alkane, we replace E by ol, then the name of the alcohol becomes alkanol. Example, CH3OH, the alkane formed of one carbon is methane. We replace E by ol, then the alcohol becomes methanol. 2 carbon, CH3CH2OH, ethane, we replace E by ol, ethanol. Benzene with OH or 6H5OH. Benzene, the name of systematic name of benzene is phen. We replace E by ol, then the name becomes phenol. Now, if the number of carbon atoms bigger than 2, the carbon atoms of the main chain are numbered such that the position of the OH group, hydroxyl group, is given the lowest possible number. In the example, we'll explain it. For example, CH3, CH2, CH2OH, we have 3 carbon atoms. If we number from this direction, then the carbon holding the OH, its number is 3. While if we count from this direction, the carbon holding the functional group, its number is 1. Then the correct direction of numbering is the one that gives the lowest number for the carbon holding OH. That means this is the correct direction. The alkane form of 3 carbon is propane and OH propanol, but OH is bonded to carbon number 1, then its name is 1-propanol. 1 for the position of the hydroxyl group. The second example, same number of carbon, propanol, but OH on carbon number 2, then its name is 2-propanol. Now, in branched alcohols, that means the carbon chain is branched, OH group takes the lowest number in preference over all alkyl groups. That means the lowest number of OH is the direction that gives the lowest number of OH is the correct direction of numbering. Example, the main chain of this alcohol is the one on the line, which has the longest straight chain holding the hydroxyl group. And we have 2 methyl group. Now, if we count from this direction, the carbon holding OH, its number is 1, 2, 3, 4. But if we count from this direction, the carbon holding OH, its number is 2. Then this direction gives the lowest number of OH, then this is the correct direction. The main chain formed of 5 carbon, then the alkane formed of 5 carbon is pentane. We add all, then its name pentanol, and all on carbon 2, then 2-pentanol. And we have 2 methyl, that means dimethyl, on carbon number 3. If we count from the direction is this direction, 1, 2, 3, this carbon number 3. Then the 2-methyl on carbon number 3, then 3 dimethyl 2-pentanol is the name of this alcohol. 3-dimethyl 2-pentanol. Another example, the main chain, if we count from this direction, 1, 2, 3, 4, 5, 6. This carbon chain formed of 6 carbon. But this carbon chain does not hold the hydroxyl group. Then this could not be considered as the main chain, since the main chain should hold the hydroxyl group. Then the main chain is formed of 1, 2, 3, 4, 5. This main chain is the longest carbon chain that holds the hydroxyl group. Formed of 5 carbon, pentanol, and all on carbon 1, 1-pentanol, but we have ethyl group and 2 methyl groups. This is carbon number 1. This is carbon 2. This carbon 3. This carbon 4. The ethyl on carbon 2 and the dimethyl 2-methyl on carbon 3,4. The alkyl groups, the order of naming of alkyl groups is the alphabetic order. Ethyl begins the letter E, methyl with the letter M, E before M, then we write ethyl before methyl. Then the name is 2-ethyl, 3,4-dimethyl, 1-pentanol. This is the name of this alcohol. 2-ethyl, 3,4-dimethyl, 1-pentanol. Application 2. Given the systematic name of the following alcohols, A, B, and C, we should determine or write the systematic name of each alcohol. First alcohol, the main chain formed 1, 2, 3, 4. This is the main chain holding the hydroxyl group, and we have 2-methyl. This carbon number 1, 2, this carbon 3. Then 4-butane, that means butanol, all on carbon 1, 1-butanol. Between number and name we write dash. And we have dimethyl, one on carbon 2 and the other on carbon 3, 2, 3. Between two numbers we write comma, and between number and word we write dash. 2, 3-dimethyl, 1-butanol. The second alcohol, main chain formed of 1, 2, 3, 4, 5. We have OH on carbon 2. We have dimethyl on carbon 3. Then 3, 3, dimethyl, formed of 5-pentanol on carbon 2, 2-pentanol. Now, the benzene, the systematic name of benzene is, or C6H6, is phen. But when the benzene is connected as alkyl group to a carbon chain or as C6H5, then it's called phenyl. As alkyl group, it is called phenyl group. Then this is phenyl, and the main alcohol formed of one carbon is methanol. Then its name is phenyl methanol. This is the end of part 1 of chapter 9, alcohols.